My name is Zachariah Threet from Tennessee Tech University, and I'll be presenting our demo. We have implemented a segmented testbed that uses name data networking for transport between segments. NDN simplifies networking with two types of data packets: an interest sent by the consumer, which asks for a piece of data by name, and a data packet which encodes the content of the respective name and is sent in response by the producer. NDN is a promising choice for vehicles because of its data-centric focus that more closely mirrors the internal communications of modern vehicles. Further, NDN's relationship with security by design promises to mitigate many common vulnerabilities. Our testbed has two Raspberry Pis acting as NDN gateways that can communicate using both Ethernet and CAN. These nodes were used to tunnel CAN messages over NDN. The other two Pis represent CAN ECUs. These were connected to the NDN gateways over CAN using CAN hats. Public keys were exchanged before the test for the purpose of signing and validation between the NDN gateways. In our tests, we have a producing ECU replay real CAN messages to the producing NDN node, which then buffers those CAN messages in an array. Here we can see the producer ECU sending those messages and the NDN producing node receiving them. Transmission rates have been lowered for demonstration purposes. We can initiate interest requests at the NDN consumer. In the logs, messages relating to NDN are indented. When interests are received at the NDN producer, the relative CAN message is read from the buffer and converted into a signed NDN data packet before being forwarded back to the consumer. Looking at the consumer logs, we can see that after the message is received, it is converted back into a CAN packet before being sent to the consuming CAN ECU. And here we can see the consuming ECU receiving those messages. We also performed tests where NDN packets were made and signed at the time CAN frames were received and then buffered before being sent in response to an associated interest. We found that the interest response times for pre-creating the NDN packets was up to 2 times faster than when we created them on request.